Hello everybody. This video is going to summarize the main points coming from Open Up Resources, Unit 1, Lesson 3, entitled Making Scaled Copies. Now to give you some context as to where this lesson falls, in the previous lesson we talked about finding a relationship between corresponding side lengths in figures. And we had figured out there was a relationship through multiplication that enabled us to see that every single side length was being multiplied by the exact same number. We call that number that every single side length was being multiplied by the scale factor. So a factor is a number that is used to multiply with, and scale means we're either going to make it bigger or make it smaller. So we're going to use the scale factor today in order to actually make the drawings. Yesterday we were just looking at the relationship. In this lesson we are going to be focused on making scaled copies by multiplying side lengths, corresponding side lengths, by the same factor. Okay, so in this task here we are asked to draw a scaled copy of either figure A or B using a scale factor of 3. And when it says that we're using a scale factor of 3, it means that we are multiplying every single side length by the number 3. So each of these side lengths are going to be 3 times what they are now. That means this figure, this polygon, is going to end up being bigger than what it is. I'm choosing to draw figure A instead of figure B, and let's do that at this time. So the first thing we need to do is write the side lengths of each of the figures. So in figure A we have side length of 2 units according to these grid lines. We can always find the lengths of horizontal and vertical lines, and I'll tell you what we do for diagonal lines. So this vertical line has a length of 1, 2, 3 units, and this horizontal line has a length of 1, 2, 3 units as well. Now for these diagonal lines, we don't know the actual length of the line. You'll learn how to determine the length of diagonal lines when you get to 8th grade. However, we do know that this diagonal line goes across for 1 unit, and it goes up for 3 units. So we're going to take 3 times that. So instead of it going across for 1 unit, this diagonal line, it's going to go across for 3 units. And instead of going up for 3 units, it's going to go up for 3 times 3 units, which is 9 units. So we're going to multiply every single length by 3. So 2 times 3 is going to be 6. So let me draw this corresponding horizontal line right up here. It's going to go across for 6 units. And not 6 units according to the ruler. I'm just using the ruler as a straight edge. But 6 units according to the grid lines. So 1, 2, 3, 4, 5, 6 units across. And then 3 times 3 for this vertical length is going to be 9 units. So it'll go down for 9 units. And it's going down a vertical line, so let's do that. Alright, down for 9 units. Down 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it's going to go across for 3 times 3 units, which is 9 units. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then remember we said this was going to go across for 3 times 1 unit, which is 3 units, and it does go across for 1, 2, 3 units, and it's going to go up 1, 2, 3, and so 3 times this is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And it does. So let's just move the straight edge so that it's lined up where this point starts and where this point ends. And let's draw a length. And this is a scaled copy of this figure right here. And we can verify that this is 6 and 9 units, and then whatever this length is 3 times the size. Alright, let's go on to drawing a scaled copy of either figure C or D using a scale factor of 1/2. What does that mean? It means I'm multiplying every single length by 1/2. And what does it mean to multiply by 1/2? Well, let's identify what this actually means. It means that we are going to divide the length by 2, and whatever we get is going to be multiplied by 1. So essentially we could just divide by 2, but we need to multiply by 1 just to remember what it means to multiply by a fraction. Okay, so this we're going to, because I dealt with a polygon in A, let's deal with a figure of just lengths. So we're going to pick D. So we'll draw a scaled copy of D, figure D. Alright, so we are going to label the lengths. This is, we don't label the diagonal lines lengths, but this is a length of 2 units across. We don't label the diagonals. This is a length of 2 units down. We don't label the diagonals, and this is a length of 1, 2, 3, 4, 5, 6 units across. Alright, to draw this, the diagonals, we know that it's going down for 1, 2, 3, 4, 5, 6 units, so we're going to take half of that, or divide 6 by 2, and we get 3, and multiply 3 times 1, and we get 3. So this should be going, this right here, this diagonal, should be going down for 3 units. Let's look at this one right here. This goes across for 2 units and up for 2 units. So half of 2 is 1. So this would only go across for 1 unit, and this would go up for 1 unit. So let me draw that here. All right. Just 1 unit up and 1 unit across. And then half of 2 we said was 1, so this is going to go across for 1 unit. 1 unit according to the grid lines. Okay. Then this is going to go down for 1 unit and across for 1 unit. There we go. And then this is going to go down for 1 unit. And then this is going to go, we said this goes down for 3, so this goes down for 6 units in this copy. So 6 divided by 2 is 3, and 3 times 1 is 3. This is going to go across for 3 units, and down for 3 units, and across for 3 units as well. This will go across for 3 units. 1, 2, 3 units. And then we said that this was 6 times 1/2 is going to be 3 as well. So we will have this corresponding length go across for 3 units. And this is a scaled copy of this 2 right here. Okay? Alright, so we learned that to create scale drawings, we need to make sure that we figure out the lengths of the segments and then multiply them by the scale factor, and then make sure that we follow the exact way that they're drawn here according to their angles. We used a straight edge to figure that out. Let's move on to this one. Our next task asked us to think about what operation is actually being dealt with when we talk about scaled copies. So it says Diego and Jada want to create a polygon so that they're scaling this polygon. That means they're multiplying each side length by a particular number or a particular factor, so that the side that corresponds to 15 units in the original, so the side that corresponds to this length right here, which is this one, is 5 units. 5 units in the scaled copy. What number am I multiplying 15 by to get to 5? Well, if I divide 15 by 15, I get 1, and then 15 divided by 1 is 15 divided by 15 is 1. And if I multiply that by 5, I will get 5. So this is in fact the number that I multiply 15 by, 5/15. Okay? So if I were to look at this, I could also say that this fraction is equal to 1/3, but I don't have to do that because both 5 can multiply 1 to give me 5, and 5 can multiply 3 to give me 15. And that is using the equivalent fractions theorem. Alright, so it seems like we'd be dividing all of these side lengths by 3 and then multiplying by 1, which is the same as just dividing by 3. So I'd multiply by 1/3, and if I multiply this side length by 1/3, this side length should be, so 30 times 1/3 is going to be 30 divided by 3, which is 10, and 1 times 10, which is 10. Is this 10? No, that's not 10. So it looks like Diego's drawing is not following the rules of making a scaled copy, but Jada's is, because this corresponding part is 10 as well. So 36 divided by 3 is 12, and 1 times 12 is 12, and that's what's here. 18 divided by 3 is 6, and times 1 is 6, so this is 6. So it seems like every single side, let's keep on going just to make sure. We already know that this corresponds to that. 12 times 1/3 is 12 divided by 3, which is 4, times 1, which is 4. And then 21 times 1/3 would be 21 divided by 3, and that's 7, and 1 times 7 is 7. So it seems like Jada is actually following what we do here. So the conclusion here is that we multiply all segments, all line segments, or lengths, by a scale factor. So in creating scale drawings, we multiply all lengths by the same scale factor. If you look at this right here, it looks like Diego did subtraction. He thought that you subtracted the same number from every side because he's done the exact same thing. 36 minus 10 is 26, 18 minus 10 is 8, and he kept on going. But as you can see, Diego's drawing is not a scale drawing because there's this big opening right over here that doesn't exist in the original drawing. And it looks like this was just squeezed a whole lot right here. Okay, so this is a scaled copy. Jada's drawn a scaled copy of this right here. Alright, in the last exercise, we were asked to, we were told that Andre wants to make a scaled copy of Jada's drawing so that the side that corresponds to 4 units, and Jada's drawing is right here, so this side right here that corresponds to 4 units in Jada's polygon is 8 units in Andre's scaled copy. So it's going to become 8 units. What am I doing to 4 to get to 8? I'm multiplying it by what number? This is how I determine the scale factor. 4 times what number equals 8? 4 times 2 equals 8. So the scale factor for this, for Andre's copy, is going to be 2. So that means we're going to multiply all of these lengths by 2. So we're going to create a scaled copy. so that Andre's figure is every single length is 2 times the length in Jada's drawing. We're going to use the edge of an index card or paper to measure the lengths that we need to draw the copy. Okay, so here is my here's my index card, and this right here is this length right here. Let me just mark it off. From here to here, right there. So therefore, I would draw 2 of these lengths. So if I were using an index card, and it's kind of challenging to use it with this tool, but if I were using an index card, I would mark off this length right here on the index card, so I draw a little tick mark right here, and then I would draw a length. I put the index card right here and draw from here to where this tick mark ended, and then where that tick mark ended, I would move my index card from this beginning of the index card to where this mark was, and I would continue to draw another segment because I'm drawing 2 of those. To make things simpler for me, what I'm going to do is use my ruler, and I'm just going to measure the length that's in this drawing. Let me just get rid of this line segment. I'm going to measure the length of each of the segments and then just double them, okay? Or multiply them by 2. So this is this goes 3.5 centimeters. So doubling that would take me to 7 centimeters. So I'm going to draw a length of 7 centimeters. Okay. And then this segment right here is how many centimeters? Looks like it's 1.5, so I'm going to double that to be 3 centimeters. And then this segment right here is 1.5 centimeters, so I'm going to double that, and that'll be 3 centimeters. So right there, 3 centimeters across. And then this segment right here is 1 centimeter, so I'll double that, 2 centimeters. I'll go from 2 to 0. And then this segment right here is 2 centimeters. No, is it 2 centimeters? Yes, 2 centimeters. Alright, so then I'll double that. 2 times 2 is 4, so I'll go across for 4 centimeters. And then this, I could just close out, but let me just verify. This measures 2.1, 2.6 centimeters. So I'll double that, and this should be 5.2 centimeters. Let's just verify. Alright, let's just go one more time. .6, okay. And then this right here, 5.2. Alright, so let me just close this out. And let me just take my... It's a little tricky when you're drawing this on using technology instead of using an index card. But this is how it would actually work. So this is how you would make a scaled copy of this. And to summarize, creating a scaled copy involves multiplying the lengths. So we are multiplying the lengths in the original figure by a scale factor. Scale factor is the number that you are multiplying every single side length by to scale it, to make it either bigger or smaller, or if the scale factor is 1, to keep every single length the same. One thing that you should observe is that if you're multiplying by a scale factor that is greater than 1, then the figure should get bigger. And if you're multiplying by a scale figure that's less than 1, the figure should get smaller. For example, to make a scaled copy of triangle ABC, as you can see here, where the base is 8 units, we would use a scale factor of 4. So scale factor is the number that multiplies each corresponding length. So this length matches this length right here because corresponding parts are located in the same location or the same position in copies. So multiply this by 4. I would essentially do the exact same thing to this length right there. And 2 and 2400ths, or 2.24, is multiplied by 4 to give us 8 and 9600ths, or 89600ths as well. So I hope that you got the main points out of this, is in that multiplying side lengths is what we do when we make scaled copies of figures from original figures. And we use a scale factor, and that scale factor is the number that multiplies every single side length to give us the new measurements. And that number has to be the exact same number. Hope that you enjoyed this video and come back for some more videos throughout your Open Up Math experience. Take care, everybody.